Howdy. You stumble across clues everywhere. So do I. It's just that you sometimes have to put a little bit work into figuring out what's the thing about. So some days ago, I found myself with this toy in my hand, which is obviously a dragon, and it says Krakow. So I thought there must be something to this story. Maybe I made a similar video in the past, I don't know. Could be. If so, just take it as a recapitulation. It doesn't change the facts. So this is one site I found. There are several of these. Krakow Info. Dragon's Lair, the Wawel Cave in Krakow. There's a dragon. Dragon's Den, cave exploration in central Krakow. Tradition connects the beginnings of Krakow with one Prince Krak. Settle it. Who rid his people of a dragon devouring both their stock and their virgins. For centuries, a large 200-foot-long natural cavern in the western rocky slope of the Wawel Hill above the Wisla riverbank has been known as the Monster's Den. Today, the cave still attracts swarms of visitors. In fact, the Dragon's Lair, Polish Smoska Yama, is the area's oldest residence inhabited by men from the Stone Age through the 16th century. Visiting the Dragon's Den, and I searched for some, here, fire-breathing monster. There's a sculpture there which is breathing fire as well. So now let's search for some pictures still. But actually, visiting the Dragon's Den, visitors can enter it via a turret of the west fortification atop of the Wawel Hill. There is a ticketing machine at the entrance, but tickets to the Dragon's Lair are also available at the Royal's Castle main box office. A long spiral flight of steep stairs, 135 steps, takes visitors down to a succession of 3 chambers under the Wawel Hill. The staircase is a converted well of the 19th century. The staircase is a converted well of the 19th century. So there has been water coming out there. The underground route is just 18 meters in length. The second largest cavern is 25 meters long and 10 meters high. The place is well lit with electric lamps. Tourists can see only part of the 270-meter-long Wawel Cave. The rest of it, including 5 underground ponds and narrow passages, are too dangerous and off-limits to visitors. The exit leads through the mouth of the cave situated next to the embankment upon the Wisla River. Do they have any pictures here? No. Now let me show you a picture. Now let's check just the easiest one. Let's go to Wikipedia. Smoska Yama. Polish for Dragon's Den. It's a limestone cave. Yes, I probably have mentioned limestone in the past when talking about mountain water, wide rivers. Yeah, look at that. Morphology. Smoska Yama has 2 entries, one natural and one artificial. A 19th century waterwork well. They are connected by 3 large chambers. A side passage discovered in 1974 leads under the St. Stanislaus and St. Wenceslaus Cathedral. I recall, I have been mentioning this many times, that I think, after some pondering, I came to this conclusion that many churches, probably almost all of them, maybe not the most recent ones, but the elderly ones, they are actual fortresses in order to protect the water. That's why they are built like they are built. You cannot break in there. It's because of the water inside. The holy water. And now here, for example, in Poland, the side passages lead to two sacred places. In the underground pools, lives are rare. There is something living. Crushes and drogebloint. Ni Fargus tatrensis, relict of the tertiary sea fauna. In the underground pools lives a rare. There's an animal. So, here we have the dragon, statue of the dragon. Ain't it interesting? Limestone, water, holy places, and stuff like that. Dragons. Now I've been pondering about water, and I think it's a very interesting thing. For example, let's check out a paper from the Journal of Chemical Physics. And if you stumble across a paper which has a title like that, you probably know that's, how to say, a real paper. Connection between liquid and non-crystalline solid phases in water. Published online 8 September 2020. So that's rather recent. United Kingdom, School of Mathematics. Yeah. Anyway, I don't know if I can show this. Probably I can. I just do it because I don't get any money. It's for education. Knowledge should be free for everyone. We are here to learn. Everybody should be here to learn. But most aren't, you know. They play video games and stuff. Anyway, abstract. The origin of water anomalies hides in an experimentally inaccessible region of the phase diagram known as no man's land, bounded at low temperature by the domain of stability of amorphous gases and at high temperature by the homogeneous nucleation line, below which liquid water loses its metastability. The existence of at least two different forms of glass on one side, i.e., the low-density amorphous and the high-density amorphous ices, and of one anomalous liquid on the other side, points to a hidden connection between these states whose understanding has the potential to uncover what happens in no man's land and shed light on the complex nature of water's behavior. Here we develop a neural network scheme capable of, or capable, I don't know, sorry for that, of discerning local structures beyond tetrahedrality. Applied over wide regions of the water's phase diagram, we show that the local structures that characterize both LDA and HDA amorphous phases are indeed embedded in the supercooled liquid phase. Remarkably, the rapid increase in the LDA-like population with supercooling occurs in the same temperature and pressure regions where thermodynamic fluctuations are maximized, linking these structures with water's anomalies. At the same time, the population of HDA-like environments rapidly increases with pressure. becoming the majority component at high density. Our results show that both LDA and HDA are Gini glasses and provide a microscopic connection between the non-equilibrium and equilibrium phase diagrams of water. Introduction. Water is unique in many ways. Water is unique in many ways. Remember, we are reading like this kind of state-of-the-art scientific paper. They are saying in the first sentence, water is unique in many ways. In other words, they don't really understand the water. They don't know. This is what this one sentence tells you. 6 words, and the truth about them not knowing water is revealed. You know? This is just one little thing I just wanted to point out, that how you can read scientific papers. What information you can get out of these. Water is unique in many ways. Its crystalline phase diagram is by far the most complex of any pure substance and still far from being fully explored. Yes, maybe my estimation of the real meaning of the first sentence was correct after reading the second sentence. However, even more surprising, yes, we are continuing the same paradigm, them revealing that they don't know. If they are surprised, this indicates that they don't know. Anyway, however, even more surprising is the existence of multiple amorphous ice forms. The first one is the low-density amorphous ice, likely the most abundant form of ice in the universe, that can be obtained, for example, by rapid quench of liquid water from ambient conditions to very low temperatures. By compressing isothermically LDA or hexagonal ice, IH, I think, a first order-like phase transition is encountered, which produces high-density amorphous ice, with a density increase of the order of 20% to 25%. Remarkably, LDA can be recovered by isothermal decompression and isobaric heating of HDA at different pressures. Broadly defined, the LDA and HDA acronyms encompass a larger set of subfamilies characterized by different thermal histories, such as the LDAI and LDA1 and LDA2 are more ordered low density phase obtained upon heating ice. 8. The annealed and very high density amorphous ices EHDA and VHDA. Furthermore, intriguing connections. Once again, wherever you stumble across this intriguing, surprisingly, or whatever words, they are telling you straight that they don't really know. This is what it means. And this is something very profound to understand. That they don't know. Oh yeah, there are researchers, they are working for universities and trying to figure stuff out, but they don't know. Furthermore, intriguing connections worthy of further investigations. Yes, the money has to come in. They need a salary, you know. Between HDA produced upon isothermal compression of IH or of LDA and ice 1,4-I4, I don't know, have been recently reported. The very nature of amorphous ice is therefore still highly debated, but even less is known about their connection to the liquid state. The liquid phase is hypothesized with support from numerical simulations, to exist in two different phases below its second critical point, named as low-density liquid and high-density liquid, respectively. Let me show you another paper. So that's another paper about the water. Journal of the American Chemical Society, 2018. Water is a kg liquid. Really? Faculty of Chemistry and Chemical Technology, University of Ljubljana, Slovenia. Lair Center for Physical and Quantitative Biology and Department of Chemistry and of Physics and Astronomy, Stony Brook University, Stony Brook, New York, United States. Abstract. Liquid water is considered poorly understood. I have been mentioned this several times, sometimes when you read scientific papers. You don't need much more than the abstract in order to somehow understand what they know and don't know. So now, even though I wouldn't have been downloading this paper, they say it in the first sentence. Liquid water is considered poorly understood. So now you can ask yourself, how much point does it make to read even further? You know? How are water's physical properties encoded in its molecular structure? We introduce a statistical mechanical model, cage water, of water's hydrogen bonding and the Lennard-Jones interactions. It predicts the energetic and volumetric and anomalous properties accurately. If something is understood, it cannot be anomalous anymore, so it is not understood. Yet, because the model is analytical, it is essentially instantaneous to compute. I don't know what this means. It can be changed, or maybe it could be wrong, I don't know. But that's scientific language. They are trying to obscure facts with using complicated language. It's a really simple tool. And totally for free. Yeah, maybe needs time to get all those words learned, but if you know them, it doesn't cost a thing to use them. This model advances our understanding beyond current molecular simulations and experiments. Water has long been regarded as a two-density liquid, a dense Lg liquid and a looser Hb1. Instead, we find here a different antagonism underlying water structure. Property relation. HBs in water pairs drive density, while HBs in cooperative cages drive openness. The balance shifts strongly with temperature and pressure. This model interprets the molecular structures underlying the liquid-liquid phase transition in supercooled water. It may have value in geophysics, biomolecular modeling, and engineering of materials for water purification and green chemistry. Introduction. A goal of materials science is to model how the properties of materials derive from their molecular structures. For liquid water, this has been difficult. Despite its importance and extensive studies, liquid water is considered poorly understood. Water has anomalous properties in its ambient and supercooled density, compressibility, expansion coefficient, and heat capacity versus temperature and pressure. It is difficult to model because of water's strong cohesion and incommensurable forces. Like other molecules, water has radial, repulsive, and attractive forces. If you have ever heard about electromagnetism, there should ring a bell. Repulsive and attractive forces. However, unlike most others, water molecules also engage in strong tetrahedral hydrogen bonding, which drives intermolecular heterogeneous cage-like clustering. I wanted to show you quickly something from Gerard Pollack, Electrically Structured Water, 2013 Thunderbolts project.
So in terms of generality, many hydrophilic surfaces generate exclusion zones, and many solutes are excluded from it. Okay, so question 2 is this zone really physically different from bulk water? I've alluded to the possibility that it might be different, but I haven't shown you any evidence. Well, I'm not going to show you a lot of evidence because it will take a lot of time, but I'm just going to summarize most of the evidence and show you some of it. And a lot of the evidence is published, and the stuff that the rest that hasn't been published will be in my new book, which should be out in 2 or 3 months. So the first is that these easy water molecules are more constrained than bulk water molecules. They're also more stable.
Yes, I just wanted to show you still a picture. I think he has somewhere here. Now let's have a quick listen where he is.
Because of symmetry, and I would have gotten pretty much the same result. So the ability to shift in each of 6 directions gives a lot of latitude. For example, you can build structures like this, helical structures. And so here you've got layer 0, the first layer shifted this way by 0 degrees, 60 degrees, 120 degrees, giving you a helix. So why is a helix important? Well, helix is important because, as you know, in biology, most of the molecules are the fibrous proteins, for example, in DNA and RNA, they're all helical. And it's known that these entities are surrounded by some kind of ordered water. So it's possible that this creates a nice interface with those molecules.
So now, what if water, liquid water or water, is not a liquid? It is an actual crystal. Because it's almost incompressible, it exhibits this hexagonal structure. And yeah, there is no such a thing like liquid crystals. Because we have here a definition: a crystal or crystalline solid is a solid material whose constituents, such as atoms, molecules, or ions, are arranged in a highly ordered microscopic structure, forming a crystalline lattice that extends in all directions. If you think about what Gerard Pollack explains, if you haven't seen his presentations, do it first. It might help. But anyway, if you have water, like put it in a bucket. There is this easy water around on the outer side, but if you start to move it, the water, the light gets refracted. Some say it's because of the surface, but I think because water is incompressible, if there is movement, it will immediately transfer through the whole body of liquid. And it will react, and it can only react because it has those strong hydrogen bonds, which forms those hexagonal lattices and stuff like that. So, is it possible the still ongoing confusion about the liquid water is because it is not a liquid in our sense? Because I think it could be a liquid crystal. Yes, maybe it's the only liquid crystal there is. That's why it's not understood. Maybe it would help if some people who know stuff would make research about that. Look at water from a new perspective. Look at it as a liquid crystal, as a crystal, not as a liquid. Maybe many of those anomalies and surprises and whatever stuff, they would just go out of the window. And it was there all the time in plain sight because it's somehow, you can see through it. There's no color and stuff. What if water is actually the only liquid crystal? It's very flexible, but almost incompressible, so it is in a way solid. Yes. But anyway, I leave it here. Thanks. Bye.